Okay, so today we're going to cover 3.2, which are characteristics of different graphs, or characteristics of different functions. The first two we're going to cover are positive and negative descriptions versus something like an increasing or decreasing description. Both of these are very, very simple. When you see how they're done, you're like going to be, oh, okay, I understand this. The part that's confusing is the students will flip-flop the terms. When we see increasing, sometimes they'll put positive. When they see positive, sometimes they'll put increasing. Same with negative and decreasing. They'll just flip-flop them. So we're here to kind of like settle the difference between what is what. Positive and negative describe if the graph is above or below the x-axis. So the first thing we need to know is, what is the x-axis? Is it the one that's horizontal or is it the one that's vertical? The x-axis is the one that is horizontal, which means the one that's vertical is going to be the y-axis. So I have a horizontal and a vertical axis. I'm actually going to go ahead and I'm going to label all of my axes like that. So I have an x and I have a y. Okay. And the increasing and decreasing is describing the slope if the graph is moving up or down. So we have increasing versus decreasing, increasing versus decreasing. A positive, negative, just think about it, is what is above the axis is positive, what is below the axis is negative. That's what we're going to be doing here. The other thing we're going to be doing is kind of brushing up on a lot of our graphing skills, because remember, on Friday, we're going to need our graphing paper. Big deal about graphing paper is it's part of our school supply list. Make sure you've got that. I do have some to lend out, but it does cost some participation points because I'm having to provide the resources for you. It's not a big deal here or there, but if you constantly, and I have to provide the graphic paper every day, graphic paper is expensive, and I got 160 of you guys. So I'm happy to provide here and there for help, but please do try and make sure you get some on your own. It really helps me out, and it just helps you out when you're doing your homework, because I can't do it on homework. I can't give it to you then. Today is the last day where we're sketching. So again, try your best to sketch these out as best we can. I'm not really too concerned with where are these things intercepting. We do want to get to the point where we are actually intercepting on like graphing paper, because it'll show like, hey, exactly where these are at. I've done these to the best of my ability. You do the same. So on number one, let's go ahead and graph a few points. My first point is at 0, 0, which means I have not moved left or right, nor up or down. My second point is at 2, 4. What that means is that I go to the right 2, up 4, and I put my second point. The last point is at 3, 0, so I go to the right 3, and I do not move up or down. So I've got those 3. The second one is I have a point -1, 0, so I go to the left 1, and I do not go up or down, hence the 0. The second point is 1, 4, so I go to the right 1, up 4. And the last one is 3, 1. I go to the right 3, up 1. Next two, I have a point at -2, -1. -2 means I go left 2. -1 means I go down 1. The second point is going to be at 0, 2. 0 means I do not move left or right. I just go up 2. The last one, I've got 4 points. I have one at 0, -3. I have 1, 0, and 3, 0, and then one at 2, 1. Now we've graphed those points. I've kind of walked you through where they go. After we graph the lines, we're going to go ahead and label all these points, see if we remember how to graph them. So the first one we have, this point is going to be a local maxima. Maxima means the highest point. Local means there might other be points that are a little higher. So maxima means it's going to curve down, and the point on the right, it's just going to go through. Actually, let me keep this a little higher. Give me some room beneath it to write. Now, this point is going to be a local minima, which means that because this is the maxima and it curves down, the minima means that it curves up through that point. Nothing special. Minima, maxima. Why do I call it a local? Well, a local maxima means it's the highest point in its area, but is it the highest point overall on the entire graph? No. I've got that spot over there that goes much higher. Local minima means it's the lowest point in its area, but is it the lowest point on the graph? No. I've got spots way lower over there. On the next one, I have 1 maxima and 2 minima. So if this is a maxima and these are minima, that means it's going to curve down from the maxima and up from the minima. Down from the maxima and up from the minima. Now that, I would describe that as a local maxima, because I see that the two ends go much higher. It's not the absolute maxima, it's just in the general area. These two are minima. That's a local minima. It's the lowest point in its area. This is an absolute minima. It is the lowest point on the entirety of the graph. No other point goes lower. So it's not just local, it's also absolute. Think local minima versus local maxima. Local maxima is who's the smartest person in this room right now? Okay? Is that the smartest person in the world? No, I've got smarter people there and there. This is, if we go the opposite, who is the least smart person in the room? Okay? Well, there's somebody that is another room, not too far away, that's a little less smart. This person is the least smart person in the entire world. That's local versus absolute. Number 3 is about all the graphs that we're going to be graphing this chapter. It's just a straight line. No maxima, no minima. Fun stuff. The last one we will eventually graph, this is an absolute maxima. That's it. Well, if it's an absolute maxima, that means it's the top and I must curve down. And because these don't have any other special names, I just go through them. Boom. This is a quadratic. We'll actually graph that in like chapter 8 or chapter 9. I forget which one. So now that we have these graphed, let's go ahead and label them. Okay. Remember, we label them according to the x value and the y value. So I've got 2 points right here, 0, 0. No big deal. I know that I have 0, 0. The next one, I have one of two options. I know I went to the right 2 and up 4, so I can either put 2, 4 or 4, 2. Which is it? Well, the answer is going to be 2, 4, because 2 is going to be the x value. I move to the right 2, and then I move up 4. Well, you might ask the question, why do I put x first? Well, my answer is, do you know your alphabet? What comes first in the alphabet? W, X, Y, Z. So the X is always going to come first. So I've got 2, 4 before Y, because it comes in alphabetical order. Mathematicians call this process alphanumeric order, meaning it's always alphabetical and then numerical in order of descending powers. Like squareds come before single powers, cubes come before squareds, come before single powers. And so with this, x comes before y. The next one, okay, now that we know x comes before y, it looks like I went to the right by 3, and I did not go up at all, so it's going to be a 3, 0. On this one, I went 1, but I went to the left. So how do I show to the left mathematically? That's going to be a negative. So I'm still going 1 unit away from 0, but negative says I went in that direction. The next one, well, I went 1 unit away from 0, but I went in the positive direction, then I went up 4. Here I went 3 in the positive direction, and I went up 1. Sitting over here, well, I know if I go 2 in that direction, that's going to be a negative 2. And then I went 1 down. And just like going left means negative, down is also negative. This is going to be 0, 2, because I didn't go left or right, I just went up. All of these, I just went straight down by 3, so I didn't go left or right, I went down 3. Here I said 1, 0. I have 3, 0. And here I have 2, 1. So again, just getting familiar with naming our graphs. Now we're going to go back to the descriptions. So hopefully that wasn't too terribly loud because I coughed right into the microphone. The first one is we're describing positive versus negative. Remember we said that positive is anything above the x-axis. If I can balance that. All right, there we go. Negative is going to be anything below the axis. So I'm just going to find where on this graph is above the axis. So I'm going to cover up the other part and say, okay, anything that's above the axis is going to be positive. This is positive, 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 all the way down to right here. Once I hit that point of 3, 0, it switches over to becoming negative. So that's the only way that we need to describe positive versus negative, is I've got that portion that's positive and that portion over there that's negative. So let's do that. positive, and negative. Well, my positive, I only have one section of green. So I'm going to label this an interval notation, which means I need a starting point and a stopping point. So don't really have a whole heck of a lot of space. I think you can see a little bit over here under this board. So remember, interval notation has a start, comma, stop. And with our interval, because we're starting and stopping, I'm not going to include those points right there. And then don't forget, we're only ever concerned with the x values. I don't really care about the y values. The x values is important. That's something that most classes today, I don't want to say struggled with, but they kept forgetting to do. Again, none of this is hard where you're going to struggle how to do it. It's you're going to try and remember what way was I supposed to do it. And that's mostly what we saw. So I need a starting point and a stopping point when this was positive. Well, I know it stops at 3, 0. And I know I'm only concerned with the x value, which comes first. So I know my positive thing stops at 3. So it's something, comma, 3. My negative starts at 3. I just don't know when it stops. Okay. Well, my negative, it keeps going, going, going. So the entire right end of this graph is all negative. So 4, 5, 6, 7, 8, all the way out there is all negative. So the way that I say that it keeps going forever is I just say from 3 to infinity. This was another big thing that students struggle with because that infinity sign, they love/hate writing it. And infinity, I usually just tell them, put your pen in the center and do a loop and do another loop. So it's a loop-de-loop, whoop, just pop around like that. If you really struggle, take your paper and turn it to the side, draw the number 8, and then rotate it back. But that's okay. The big thing that I've mentioned time and time again is the infinity sign, and a lot of our writing is going to be a little sloppy in the beginning. Our job is to start now and try and make it a little better as we go. So if your infinity sign looks a little weird, that's okay. Do your best, and then over time, as we write more and more of these things, it will get better. So this is saying from 3 to infinity, my graph is negative. If I wanted to, I could write them all out. So like we said, 3 was negative, 4 was negative, 5 was negative, 6 was negative, 7 was negative, 8 is going to be negative, like as I keep going off on, but I'll never stop writing it. So I'm just going to say, hey, between these two things, everything's negative. That's why we write that. Now the positive part is going to be in reverse. So the positive part ends at 3, so I've got 3 as the last number. I know 2 was negative. I also know 2 was negative, 2 was positive, 1 was positive. 0 is also, well, 0 is a 0, but we're going to include that in there for today. Negative 1 was positive, negative 2 was positive, and then it kind of falls off my graph. But can I keep going in that direction? Yeah, I can keep going in that direction. So I'm going to say, I'm going to go all the way over in that direction, all the way to infinity, but I'm not going to the right, I'm going to go to the left. So negative infinity, I had one student ask this, and I thought it was a really good question. They're like, wait, I thought infinity was just too big to be measured. How do we have a negative and a positive infinity? Isn't it the same thing? And the answer is yes. Infinity is too big to be measured, but it's the positive and negative just indicates the direction. Positive infinity says it's too big to be measured that way. Negative infinity says it's too big to be measured in that way. That's all. So that's it. Now, I am going to come back and do the increasing and decreasing here in a moment, but what I did was I said, hey, let's ride this and go ahead and do positive and negative on the next graph, and then we'll come back and do increasing and decreasing on both of them. So for the positive and negative of the next graph, let's go ahead and write it out, positive and negative. Now the positive portion, if I were to cover up the entirety of the graph beneath it, we notice is the entire graph. So all of this, everything up here is all positive, which means it has no start, it goes all the way to the left, and it has no ending, so it goes all the way to the right. Most classes got that pretty quickly. The negative one, it took a moment, and I usually had a few kids in each one pipe it out, and they said, hey, what part of this is negative? Took them a second, and they're like, well, there isn't one. Well, what do we have in math that represents we don't have one? The answer is empty set, empty set, empty set. And now I introduce the symbol for an empty set. Just like we have for infinitely many solutions, just like we have a symbol for all real numbers, we do have a symbol for an empty set, and it's a circle with a slash through it. That says, I don't have an answer to plug in. So you could write empty set if you wanted to, or you could just write that. A lot of people say, hey, that's how I write my 0. Interesting question, because that's the philosophy behind 0. Is 0 a number, or is 0 the absence of a number? If it's the absence of a number, that means there's nothing there, hence the empty set symbol. If you're using it as a number, then you could just draw that like slightly skinny oval. So that's a 0. That's actually a squishy empty set symbol. So if you're like saying, hey, I want the number like 700, that's 7, nothing, nothing. There's nothing in the tens and there's nothing in the ones. And it's kind of cool. Little philosophy behind something you may not have realized you were writing. So those are positives and negatives. The next thing I'm going to be looking at is increasing versus decreasing. We're talking a little bit about slope. Now, we haven't actually done much with slope as of yet, but again, we're starting to introduce it or reintroduce it, and you'll see those phrases and those words popping up more and more until we actually do something with slope. Okay. So on this one, the slope, I like to say, hey, think of this as riding a roller coaster. From the left to the right of your roller coaster, what is your roller coaster doing? And so they look at this like a picture, and they're like, well, in the beginning of my roller coaster, I'm coming down. Woo, hands are in the air. And they hit down here, and then all of a sudden they hit that part, where the crank starts pulling you back up, and you make it to the top of another hill, and then, woo, my hands are in the air. Oh my gosh, this ride will never end. That'll go down to forever. So I'm like, okay, I see that I have two portions of this graph that are negative, not negative. Told you this was going to get confusing with the terminology. Two portions of my graph that have a negative slope, which means they are decreasing. I have one portion that is increasing. So let me write increasing. And I have one portion. Decreasing, I have two. So I have 1, 2. My increasing portion is easy. I'm increasing from 0, 0 to 2, 4. But again, I don't care about both values. I just care about the x value. So from 0, 0, the x value is 0. To 2, 4, the x value is 2. I'm going up from 0 to 2. I'm going down. Well, I know my first portion stops at 0, and my next portion starts at 2. So I've got those things. I also know that my right decreasing portion never stops decreasing. I'm going to go all the way to the right, and you're still plunging down. As long as time is in existence, you are plunging down in that roller coaster. Sounds horrible. I also know that because there was no beginning in sight, I must be going unimaginably far in that direction as well. And then a cool little tidbit that I point out is I said, hey, one of your homework questions is going to be you're going to have to get these information and work it in reverse. You'll notice that these tend to pair up. The 0 pairs up with the 0 right here, and then the 2 pairs up with the 2 right there. So you make a full circuit from negative infinity to 0, going down, pause. Oh, there it is. 0 to 2, I'm going up, pause. Oh, and then from 2, I'm going back down. So they match up with each other. On number 2, we have an increasing portion, and we have a decreasing portion. Okay. Again, let's ride the roller coaster and see what is going on here. So as I start the roller coaster, I'm plunging down, woo, coming down, 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 and then I'm coming up, 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 up. I'm at the top of the hill, and I come down, 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 and then I crank up, 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 click, 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 and I have to ride that clicking all the way up to forever, and I never actually get to go down the roller coaster again. So here I see 2 red portions and 2 green portions. My 2 green portions are the 2 portions where the graph is increasing, and my 2 red portions are where the graph is decreasing or where it's falling. So my first increasing portion is from negative 1, 0 to 1, 4. Again, I'm only concerned with the first number, which is the x number. So from negative 1 to 1. My second portion is from 3, 1 onward. Again, I'm only concerned with the x portion, which is 3. And then I say, hey, I never stop increasing, so I go all the way to the right, which we show as infinity. The decreasing portion, again, students get most of this. It's that part that they don't get. They see that it stops at -1, so they get that. They see that it starts back up at 1 and then ends at 3, and they get that. It's where does it start? Well, they see that arrow going upward, so a lot of students say, hey, it starts at infinity. And they forget that it has nothing to do with the y values. It's only about the x values. So the x value is all the way over in that direction. So is it an infinity? Yes, but it is a negative infinity. And so again, we talked a lot about, hey, neither of these are really difficult, but you can see how the terminology gets a little confusing. So a lot of what we did was just focus on, do you know which is which? Positive versus negative, which part is above and which part is below, versus increasing and decreasing, which is what the graph is doing. I can have an increasing portion that is beneath the line. I can have a decreasing portion that is above the line. They don't mean the same thing, but they sound pretty similar. The second thing we went over was intercepts. An intercept is where the graph touches an axis. So if I have an x-intercept, it touches the x-axis. If I have a y-intercept, it touches the y-axis. And now I put here, I said the x-intercept always has a 0 for the y value, x and then y. And the y-intercept always has a 0 for the x value, so 0, whatever the y is. And then we ask ourselves, why, pardon the pun, why is that? So let's go ahead and list this. I'm going to have my x-intercept, and then I'm going to have my y-intercept. Okay? And then the best way that I find to explain this is just let's highlight what we know. What's the easy part? My x-intercept crosses the x-axis, which is this one, right about here, which is about, it looks like on my drawing, that's about at -1.5. If this was actually drawn to scale, it would be -1.3 repeating. But let's just go with what we see. Again, this is a sketch. It doesn't need to be exact. So my x-intercept is at -1.5, and my y-intercept is up here, and that's at 0, 2, or I should just say 2. Okay? Now, the big confusion is that's not the actual answer. I need a coordinate. And now, if you remember the rule, x always has a 0 for y, y always has a 0 for x, awesome. But let's work this out and just figure it out intuitively. The x, I know, okay, I need a set of directions, but I don't remember if it's 0, -1.5 or -1.5, 0. Well, if the 0 is first, that tells me my x and then my y because of the alphabet. Whereas if the 0 comes afterwards, that's my x and that's my y. And remember, it's the x-intercept. So which one has a value for where the x is? Oh, if the 0 comes afterwards. Secondly, we know that the x value tells us left and right. So I always want to know that first. So it says go left 1.5. So I know the -1.5 is going to be first. So that means that the 0 is going to come afterwards. So even if you don't remember which way it comes, you can always just kind of check all solutions and see which one makes sense. For the y-intercept, again, I can do the same thing. I can try a 0 out before it, and I can try a 0 out after it. If it's before, x, y. If it's after, that's the x, and that's the y. This one says I don't move left and right, and I go up 2. If the 0 comes afterwards, it says I go to the right 2 and don't go up. Well, there's only one that makes sense, and it's the one where the 0 comes first. That means that I don't go left or right, I just go up 2, which is what the y-intercept's all about. And that's it. The only thing that we really want to get in the habit of doing is if our x-intercept or if one of the intercepts isn't explicitly labeled like this one is, we go ahead and we label it. So that's going to be -1.5, 0. Now, each class had a slightly different number for this. So if your classmates have like a -1.3 or a -1.4 or a -1.1, that's okay. We were just sketching. In our sketch, we took our best guess. When we actually start graphing for the second half of this chapter, we'll actually get better answers and we'll figure out other ways that maybe if I stare really hard and I can't tell, is there a better way to do it? And there are. The last one, number 4, I asked them to try this out on their own. Some classes did really well where they got it. Some classes stared at it, they're like, I still have no idea what's going on. So let's walk through this one again. The x-intercept is where it crosses the x-axis. The x-axis is the flat one. So I see the fact that this crosses not once, but twice. So at bare minimum, the students should spot the fact that it crosses at 1 and it crosses at 3. If they don't remember the zeros, we'll work with that here in a moment. For the y-intercept, that's where it crosses the vertical line, which only happens once right here at -1, 2, 3. So at minimum, I should see this. Where we put the zeros, let's work it out. If I put a 0 before the number, that means it's 0, 1. I don't move to the left and right, but I go up 1. Is that what we're trying to say? No. So I'm going to try the 0 afterwards. Well, the 0 afterwards says I move to the right 1 and don't go up or down. That's good. I go to the right 3 and don't go up or down. That's good. So again, if you're not sure, put a 0 before and put a 0 after and see which one makes better sense. In this case, the 0 afters make much better sense because the x always comes first in the coordinate. And then do the same thing for the y-intercept. Okay, I have a -3 right here. Is the 0 coming before it or is the 0 coming after it? Well, that means I don't go left or right, I go down 3. If I put it afterwards, that means I go left 3 and down 0. Well, the first one makes better sense because I don't go left or right. The y-intercept tells me find the y-intercept by going down by 3. And that's it. That's our whole section. Now, the homework questions, the way they did it was these are the first few questions, these are the second few questions, and then you have to do it in reverse, where they give you some of these interesting points and they say, hey, sketch a graph working backwards. So really try on that last one, question 9 and 10. That one's going to cause you to really think about what do those pieces of information tell us and how can I use it to sketch a graph. Try and bring it back tomorrow and see how we do. Tomorrow I'm not going to be here for the first half of the day because we have a common planning period amongst all the algebra teachers. So I'm going to be on campus. I'll just be in the main office going through saying, what day are you teaching this? What day are you teaching that? When are you testing? When are you quizzing? How many things are you giving? What are your students doing well in? What are they not doing well in? How are these lessons going? That way all teachers in Algebra 1 kind of stay on the same page. Super exciting, or not. But the idea is that it does put us all on the same page and it kind of helps unify what we're teaching as a school. The homework for this one, oh yeah, I was going somewhere with that. Because I'm not going to be here for the first half of the day, you guys might have a sub. What you're going to have is you're going to have partners. Each one of you is going to have a desk buddied up against another desk. You guys are going to do a worksheet together. The worksheet's going to be really quickly. You should be done theoretically by like halfway through because it's what we did today and what we did yesterday. The second half of class, the review guide has been posted on Delta Math. I would suggest going on Delta Math and taking a look at it because where do I pull the test questions from? From Delta Math. So log into Delta Math, try out some of those questions. If you don't know how to do them, you got tutoring before school across the hallway, you got tutoring after school beside me or across like catty corner from me. Come, get it done. It's not graded. I even put in the assignment name, this is not graded. But that's where the test questions are pulled from. If you know how to do all the review guide questions, you know how to do all the test questions. So really try that well. But let's go ahead and write down the homework for today. The homework is for section 3.2. I'm just going to write it smack dab in the middle. So homework for 3.2 it's going to be page 113, number 1 through 10 odd. Okay? That is a grand total of, you guessed it, 5 questions, unless you're 6th period. 6th period, you guys were a little rambunctious. You guys, we're just going to do questions 1 through 10. I know I said 1 through 17. If you're watching this video, it's just questions 1 through 10. You do have to do all of them, but it shouldn't take you more than about 10 minutes. Some of those word problems, I don't know if you guys want to do them or if they're going to be too hard or how much time they'll take. So just do questions 1 through 10. So again, this is 5 questions, and this will be due tomorrow. Nope, because I won't be here for the first half. This will be due day after tomorrow on 10-3. So do 10-3. That being said, again, super easy thing. Make sure on Friday to have graphing paper because we're going to start graphing. Until then, take care.